So we did we're in some tough stuff. I think, to be honest, once today's done, we'll move on. All right, whether you understand it properly or not. All right, we can come back to it at another stage. All right, but I think I don't see you tomorrow, do I?
You do.
Such a,
Oh no.
such a shame. I'm just devastated.
We're still.
Yeah, I know. I can see it in your faces. What? So we've got this rational function. So I took this from Desmos, but obviously what we were doing is we were trying to solve these rational inequalities. So we've done the quadratic inequality. Your assessment, by the way, won't be on these, just the quadratic stuff. I think as well I'm going to try and make it an A and a D. All right, I'm going to have a D component to it, only a strand of are you able to discuss, explain, or whatever, whether it makes sense. So I'm just going to pick that one strand from criterion D. All right. So I haven't written yet. I'm planning this thing of you're going to have just a basic function to work with. You'll have to show me that you're able to do factorizing or complete square form or whatever, or find the equation from the curve or whatever it is I ask you to do. But then I'm going to have a secondary component with if this was applied to a real world scenario, okay, what would the values mean? Would it make sense? That kind of thing. That's what I'm imagining. All right. So, I'm kind of thinking it would be like one overall problem, not lots of repeated problems. So the criterion A in it will be, are you able to write this as... So let's say, I don't know yet, but let's say I give you a graph and I say, right, tell me what the function of this graph is. And you'd have to show it. And I would say, write it in standard form, completed square form, factorized form, and so on, yeah? So you're showing me your ability to do that in each stage. And then I would say, right, let's say that this graph models a particular situation. All right. Now use it to figure out certain things within this real life situation and tell me, do those values make sense to represent that? That's what I'm conjuring in my head at the moment. I'll have the time. So disappointingly that you won't be here tomorrow to write it. You know, it gives me that time. But that's my idea. That's what I think you should expect. Not just a list of factorize this, do this, right? Make sense? Cool. These will not be in it. Rational functions. Because this is the standard level stuff. It will come up later on, but we don't. So we're in the process of trying to solve these inequalities. So this one was simple enough. We came up with inequalities where x was greater than -1, x was greater than 1. So we went with the major one there, the one that overrides this one, and same the other way round. So we ended up with this inequality here, but we had to leave it as two separate ones because when we graph it, we can see they go the opposite way. All right, so we did that. We then looked at a different one where it wasn't equal to 0. It was 2 instead. So we made the first step of subtracting 2. So we've got the 0. And then we were struggling for a lot of time. So what you did eventually was you decided actually we need to combine the 2 to the fraction, all right, to make one fraction. All right. The common mistake here was obviously if you're going to subtract something, you have to subtract both terms, not just the first term. Right? So the common mistake would be for that to be a plus. And if you had that as a plus, this would be 8 minus x instead of 4 minus x. So you can see how it would change it completely. So then we went through the process and said we want it greater than 0. So we've got 2 positive, 2 negatives. We found our solutions. X is less than 4 and x is greater than -1. Or we've got x is greater than 4 and x is less than -1. right? Now, the keen amongst you realise that that meant everything was possible, which is not true, all right? So we looked at the graph, all right? And we're trying now to decide which ones are applicable. So we want where it's greater than 0, so that is where we start from this point here. Let's trouble this point now. Start from this point, which is at 4, right? So that's the 4s there. And it's greater than 0 all that time, so that's when we get to this line here, which is the asymptote, and the asymptote is at -1, which is this one here, all right? So we've got the right numbers, we're happy with those numbers. It's just the actual ones we want then are when x is less than or equal to 4.
Greater than or equal to
Not quite.
Oh, just greater than.
Okay. Could I combine those two into one thing? So could I write x? Why not the and equal to -1, given that the sign is and equal to there? Yeah, it will never equal that, so we shouldn't use that. So we've done that. It makes perfect sense, those solutions with the graph in front of me. All right? The question is, so which ones did we pick? We want x is less than 4, and x is greater than -1. So we wanted the first set, and the first set came from the both positive. When they're both negative, we got the wrong things. Why do you think? Is there any reason you want to spot that? Yeah.
Is it because the sign left given the negative, and so it's actually the same answer?
Makes sense, right?
We're dividing with negatives.
Dividing with negatives.
Sign flips.
Yeah. Yeah. Because if we take this negative section here, which is what it's saying, yeah, we're actually less than 0. It's the wrong way around. All right. So when we've got this situation, the first option here, both positives, looks like that could be the way forward. All right. So, any questions on that moment? We took basically what? It's a whole lesson of question at the moment we've been doing. All right. So you are hopefully looking at the others. I'm going to ask it, would you like to go through another one, or would you like to give it a go yourself now? Give it a go. All right. Why don't you pick a range of them and let's see whether we can get those. Feel free to, if it helps, get onto Desmos and graph it so you know what's expecting. And as long as you don't think, well, I need to be able to do this without the graphing software at some point. So feel free to put it in first and see whether you know what the answers are and see whether you can confirm it at this step. Even you two. I'll allow it. Go for it. We might be able to simplify things a little bit. So in this case, what do we know? Well, x is not allowed to equal 4. So if I was going to do a little sketch, set dotted check, barred in the way. Right. If I do a little sketch, like we say, it's quite often I said, when x is 4, so that means we've got an asymptote at 4. So that's a good thing to realise that. If we then solve, well, we're saying that both of these have to be greater than 0, yeah? So this one would be, well, x plus 1 greater than 0, we would say x has to be greater than -1. right? And we've got x minus 4 has to be greater than 0, so we've got x is greater than 4. So that would suggest that this region here, the line is going to be above this x-axis here. And it also suggests that at -1, right, that the opposite is true. That not the opposite, but it's also above. That's what this suggests. Right? But what we should do is confirm that. Really, the easiest way to confirm it is we know this is an asymptote, so this point must be what? Where it crosses the axis. Yeah. Okay. So let's just do a check with what happens if I put x equals 5 into the whole thing. What do I get? So we can do 5 plus 1 divided by 5 minus 4, and I get, that's the y value for when x is 5. So that confirms that this is correct, yeah? So I know I'm up in this region. If I go, well, x should be greater than -1, pick a value. X is equal to 1, okay? So we'll do 1 plus 1, sorry, over 1 minus 4, and I get the answer 2 over -3, which is a negative. So that would suggest that this is not what I want. This one should actually be the other way round. Right? And that's the thing about it is the x values that we choose have to work in both of them to give a positive. Right? But we are using them to find these marker points. Right? So that means at this stage that it's actually when x is less than -1 that it's above. Right? So even if I don't know the graph, I've actually shown that it must be that way and that way. Right? Now if I get used to drawing the graph, I know then that that means that. Right? Well, what is the other asymptote that we talked about? So we've got a vertical asymptote, but we've also got a horizontal asymptote with these, if we get to know that. Where is that going to be?
Y, x
That's the vertical.
well,
Where's the
y,
y is equal to 1. Do you remember why? Because if it's x divided by x, if we add values, it will never be x divided by x alone, will it? Therefore, it will never equal 1. Right? So I've got a line, also an asymptote at y equals 1. So that gives me the clue that this graph must be looking like this. Yeah? Make sense? Right. Which we know, right, because you've all put it into your computer, I guess. But so probably the easiest way, rather than trying to think our way around it, is to do the check. Right? Check with values. Right? Again, just like with quadratics, like any function, once you become more familiar with these functions and what they look like and where they go, you'll be able to just sketch and go, I know anyway. Yeah? But that has to come with experience. So at the moment, doing these checking with values, so if I think it's greater, let's do a check with 1. Did it work? No, it didn't work. So I have to change that sign. Yeah? Whereas this one, checked it, it did work, I'm good. Right? Don't have to do anything. Make sense? If you have a fraction that is 3x plus 1 over x minus 2, for instance, Alright? So, if I just figuring out the asymptotes and stuff, well, straight away I know x is not going to equal 2, right? Just from that. Right? Where it crosses the x-axis? Well, that's going to be the top one. So 3x plus 1 equals 0. That's going to be x is negative 1/3. Why don't I need to worry about the bottom one for that? Because if the numerator is equal to 0, the whole thing is equal to 0, right? So if I were to do a little sketch now, right, I know that my asymptote, my vertical asymptote is at 2, and I know it crosses the axis at negative 1/3. Okay. Fine with that? Now the question is, what's the horizontal asymptote? What value can this never take? It's not 1. It can be 1. It's 3. Because what you have to do is, if these numbers are not the same, what it can never be is ever 3x divided by x. Which is basically 3 divided by 1, yeah? So it will never be 3. A way to say it is if I put x is equal to a really, really big number, let's just do a million, the top will be 3 million and 1, and the bottom will be, well, it's only 1 million, so be 999. Now, if I do that, it's going to be super close to 3 million over 1 million, right? Very, very close to it, but not quite yet. And isn't that the definition of an asymptote? If I added another 0, these numbers would become less and less significant. So it gets so close to 3 over 1, but never quite there. So you're right, the 3 is the other asymptote. So I can put in there at 3. And then it's a case of knowing that, well, the graph will do this, won't it? And this, because I know how they look now. And then it's a case of, right, do I need it greater than 0 or less than 0? Because if it's less than 0, I can sketch it and go, this is what I want. Yeah? If it's greater than 0, it's the other side. But you're right, the 3 adds that extra little thing, but it's not actually that hard. Yeah? What if it was 3x minus 2 over 2x plus 1? What would the horizontal asymptote be? 3 over 2, yeah? Simple as that. Because it will never quite be 3 over 2, because it would be 3 billion but minus 2, 2 billion but plus 1. So it's very close to 3 billion divided by 2 billion, but not quite. Ryan, did you sort?